So today we would be solving LeetCode question number 113, and that is path sum 2. So what we really need to do is that we need to print that root to leaf path which sums up to our given target sum. Okay. So we need to print all those paths, like for here in example we are having this tree, and if I have my target sum as 22, then what will be that root to leaf path, those root to leaf paths which would make the sum equals 22. So we are given with this basic binary tree, and if I just sum up 5, 4, 11 and 2, I get a 22. If I just sum up 5, 8, 4 and 5, I get a 22. So that is why I have added these two paths in my answer. Okay. Similarly, for target sum of 5, 1, 3 or 1 or 2, whichever way we do, we would not be able to achieve. So that's why we have just printed an empty array. And for target sum 0 and for a binary tree of 1, 2, we would also be getting an output of empty. Okay, so let us move on to the question. So what would be the basic learning from this question? We would be learning about how to iterate recursively or in our binary tree, first and foremost, and the second is the condition that we would be treating of target sum. So the basic idea that we would be getting from this question is how to iterate over our binary tree in a recursive fashion. Okay, so let us start. At the end we need to return all the paths, so that is why we would be creating vector of vector, let me just, yeah, vector int resultant, yeah, that is good. A temporary vector would be required because we would be appending our temporary vector into our res. Okay, after all this I will be calling my answer and I'll be passing in my root, okay, my target sum, my target sum, my resultant and my temp. That is good to go. And at the very end I will be returning my res, and yeah, that is it. Moving on to our answer function, that would be void answer. What we will be passing, firstly tree node star root, okay, our int target sum, vector of vector int ampersand res, and a vector of int ampersand temp. Okay, whenever we will be having our root node as a null, okay, as null, so we will be saying please do return, because no further we need not proceed further, as right now we are having a null value, and after this null value it is defined that our tree would not be proceeding further towards left or towards or right. Okay, so whenever you get a null, if uh, root roots value or not roots value, if like this, if it is not equal to, if not of root is true, that means nothing is there. So please do return. Okay, and okay, after this, if not of root, if not of root's value, val, let us try. Okay, let us try. I think that this is correct. Okay, so if we just move on, um second most thing is appending our roots value into temp. So temp dot push back root value. Okay, after pushing back it into my temp, what we need to check, if not of root left, that is left is also null, Okay, and right is also null, and our target sum is equals to root's value. Sorry, root's value. um if these are the cases, then I'll be saying res dot push back and push back my temp. Okay, what we had done here is that if we reach a node that is a leaf node, why it is a leaf? Because its left and right are null, first and foremost. Secondly, our condition of target sum should be equal to the whole summation from root up till leaf. So if the last variable that we are treating, the last node, okay, for an example, if we were at 5, we treated 5, we treated 4, we treated 11, then we are at 11's value. So what is 11's value? Oh, sorry, we are at 2. So what is 2's value? So 2's, this node's value is 2. So this node's left and right is null. Okay, satisfied. And for in this example, I'll be having my target sum that is being reduced recursively. So if it is now equal to 2, target sum is 2, and now value is also 2, root's value. So if I just subtract this from my target sum, that would result into 0. So that means my condition for target sum from root up till leaf is satisfied. Hence I'll be adding this whole tree into my resultant. So please do add this whole tree into my resultant. Okay, after doing all these things, what you need to do, go towards the nodes right and left. So answer, after answer I'll be saying root left. Okay, and then target sum, target sum minus root value, and res and temp, that remains the same. Answer root right after iterating towards all the left of that node. Now go towards the right and then subtract the root's value um, from my target sum uh, while you are traversing towards the right of that node, and res and temp remains as it is. After doing all these things, please temp dot pop back whatever last you inserted, that means this value. Okay, so far so good. And if this condition poses a problem, I think that should not pose a problem, but yeah, if that poses a problem, I think we should go and check that out. Okay, but that is correct, that is accepted, and if I just submit it, that would be accepted. Yeah, that is accepted. And this was an important question, as this was asked in many FANG related companies. And the second most important thing is that we had learned about the binary tree traversal in this question recursively. uh, if I just remove these conditions, this one, okay, this one, okay, and what else? If I just remove this condition, if I just remove this condition, and if I just remove this target sum from my function, okay, then and also this one, then I'll be getting all of my paths from root up till leaf, okay, in my answer. As you can see, if I just run it, uh, root, okay, that is okay, and that is also okay. So if I just run it, I'll be getting all the paths from root up till leaf. It will be a wrong answer, I know it will be a wrong answer, but I have received all the paths from root up till leaf. 5 4 11, 5 4 11 7, 5 4 11 2, 5 4 11 2, 5 8 13, 5 8 13, 5845, 5845, and 5841, 5841. Hence this is an important question. This is an important question because we have learned how to traverse a binary tree. So please do remember these basic functionalities of checking if the value is null or not, pushing back the value, checking that values or that nodes left and right. If they are not, if they are null, then that means this is the lead node. Hence, please push back all the values, up till now into my 2D vector of say resultant as of now. Then we iterate over the left of that node and then towards the right of that node, and then after doing all this we will just pop it back, and yeah, that is it. So that is the backtracking approach of solving or iterating over my binary tree. And what was earlier, what we have done was according to the question of getting that target sum from root up till leaf node, and then checking those values, summing them up, and then checking if that path leads us to the target sum or not, and then if yes, then appending it to my resultant vector, and then just returning my resultant vector as my answer. So that is it for the question. I hope that the discussion was pretty much clear. If you have any doubts, please do comment it down in the comment section. We'll be meeting in the next video. Till then, bye and take care.